In this video, I'm going to show you how to avoid this, and we'll go into this, and this again, since it made such a good impression last time. We're going to cover a bunch of support strategies and how to tune supports and what they're good for. Let's go. This video is sponsored by PCBWay. I should start this video by explaining support. Support is when you have a thing that you're printing and it either doesn't connect to anything underneath it, meaning it's floating, or it's going to be at too steep an angle from the previous layers of the print. These are two circumstances where you need to use support. You can get away with a lot though. I've covered in previous videos how you can forego support in a lot of cases, but this episode is about using it, not avoiding it. Also using it to get neat results too, because a lot of the time supports leave an underside that looks kind of like this, and that's quite messy. And that leads us to the first topic I want to talk about, interface. Support settings in the slicer can be confusing, especially using words like interface, but the concept of interface isn't actually terribly difficult. Here is some support without support interface, and look how few contact points you get. And the resulting print lacks support because it's relying on the same density at the top as the support structure has. And you could increase the support structure density like this. You could do that, but that would waste a lot of support material. Or you could turn on interface. Interface is kind of like a raft, I guess, at the top of the support, and it increases the surface area under the part. The denser the interface, the more points of contact you have, and the neater, in theory, your underside will be. The downside of this, though, is that supports with higher interface density become a lot harder to remove. There's not a huge deal you can really do about this trade-off either. Or is there? You see, a dense interface between two parts will definitely try to fuse itself together, but what if those surfaces were not capable of bonding together well? This is the main point of this episode, to explore support materials. Support materials are a secondary material, different to the one you're actually printing the part in, that you can print as support and then remove somehow. A good support material choice is one that can be removed without damaging the section it's supporting, but also sufficiently sticks to the part in the first place. Now, a lot of these support methods do need or work better with a multicolour printer, and I understand that. I realise a lot of people watching this don't have one, and of course that's a problem, but these multicolour printers are becoming more popular and more accessible, and there's still ways to get around it, so stick around. Pun intended, and I'll hopefully find ways to support you, pun intended, even if you have a single nozzle printer, pun intended. So the classic support material is PVA. This stuff goes way back. You probably know PVA because it's PVA. It's the primary ingredient in PVA glue, unsurprisingly, and it costs about £30 for a half kilogram reel. It's not cheap, but it's not inordinately expensive either. The texture of this stuff is somewhere between dry pasta and wet pasta, and the colour of this stuff is somewhere between dry pasta and wet pasta. The idea with this stuff is that it is soluble. You can print with it as a second material and it sticks really well, and then you can dissolve it when you're done in just warm water. This stuff has been around for so long there's probably a million YouTube videos on how to use it, but you need a 2 or more colour printer as I mentioned, but also one that can handle it, which means that the Bamboo AMS is out as it cannot handle this. I'm printing it on an IDEX here. This is the Sovol SV04. And yes, this is the same Sovol SV04 that I reviewed over a year ago. It's still working perfectly, and I very rarely tune it. A lot of people have problems with the SV04, but I don't know. Mine is fine. Anyway, that's beside the point. The reason to choose PVA over any other support material is when you need to support really awkward or even internal surfaces. I've designed a couple of pieces here. The first one is a cube where there's a ring inside it. You would struggle to support that ring with conventional supports. There's no way to really do that. I mean, tree supports might, but when dissolved, hopefully this piece will look like one of those puzzles where you have to struggle to get the ring out and there's a trick, but there is no trick. There is no way to get the ring out, and that's hilarious. The second piece is 3 balls in a cage. I don't know, I just felt like it. The third one is actually one of MZ4250's D&D pieces. This is a particularly awkward looking dinosaur These are meant for resin printing, in fact, but we can give it a go with PVA and see how well it does. And while we're at the D&D thing, we should do a dice. We'll come to this bit in a minute, and I'm going to dissolve all of these at the end. This is my sneaky way of keeping you watching, so you can skip to the end if you want. I won't stop you, but you'll miss the cool stuff. Before we continue though, I want to show you this. This is a preview of what's coming in my next non-review video. I've designed this board, I know, I'm not completely incompetent. I haven't tested it yet, so the jury's still out on that one. I've designed this board to meet my needs for the next video, but it's actually a general project board for ESP32 development, which, if you're not into electronics, might not mean much to you. The ESP32 is a microcontroller, and that's really all you need to know. You see, an ESP32 doesn't fit on a breadboard, or at least this one doesn't. And this is the source of some frustration for me. I know that it technically does fit on a breadboard, but you need to actually access the pins and it covers them. So I'm telling you all this because of the video sponsor, which is PCBWay, who obviously manufactured this board for me. I'm actually really impressed with how professional this board looks. You wouldn't guess I made it. And this is actually the first time I've used PCB manufacturing services at all ever, so this was all completely new to me, yet I was able to figure this out pretty easily. With PCBWay, you can choose all sorts of options and colours, and I chose green because at the time I ordered this, it was the fastest to produce. They will tell you how long it will take to produce each of the options you choose, but I have samples of other colours here as well. I found the whole process pretty undaunting, if that's a word. I'm the opposite of daunting. And if you at any point in the process need support, PCBWay also has customer support just a click away to answer any of your questions. You can follow the links below to check out PCBWay and try it for yourself. Thank you PCBWay for sponsoring this episode. So, the other method of doing removable supports is something that seems to have become more popular recently, and that is using incompatible plastics. The idea that you could use PETG to support PLA is becoming more well known, and it's true, you can. This technique works because PETG and PLA will stick together, but not with a particularly strong bond, so you can break them apart. The thing about using these materials, and this goes for PVA too, and is often forgotten, is that if you use them, typically you do not want to leave a space between the support interface and the part. When you print with PLA, you have to allow at least one whole layer between the support and the part. You can't do half layers, unfortunately, I don't think in any slicers, between the interface and the part. If you don't leave a whole layer, well, what you're doing is you're just printing on top like normal printing, and that will be fully meshed together when it's finished, and you won't get that apart. You have to leave the gap. But when you're using dissolvable or non-permanently binding, I don't know, I'm just making up words now, we'll call it non-permanently binding support, you do not want to leave a gap. This means, of course, that your support quality will, in theory, be better. I'm going to put on screen now a sort of grid that tells you what works with what with regard to supports, at least so far as I've tested. TPU is probably one that you might not immediately have thought about, but it's probably the most useful of all because TPU supports are pretty much not a thing. If you've ever tried to print a TPU part with supports, then you know that they don't come apart. They just stretch. TPU will apparently happily just pull away from PLA and PETG. I've tested PLA. Modbot, on his channel, he tested PETG and TPU and PLA and TPU, and he found that both works, but I think he found PLA to be the better of the two. So let's talk about Bamboo Lab then. Specifically support W. If you bought a Bamboo with an AMS, then you will get a reel of this free. If you have an IDEX, you can buy it and use it, of course. There's Polymaker Poly Support, which I've heard might actually be the same thing. This is literally just a slightly better tuned breakaway support, rather than using PETG, which of course you can on the Bamboo Lab, there's nothing stopping you, but this support works at the same temperature, so prints will be quicker, among other things, if you use it. This stuff is, I think, just a weird formulation of PLA. I could speculate, but the MSDS actually tells us what it is. Poly Support says polyurethane. Bamboo's MSDS gives away a bit more. It says exactly what I thought it was, which is a mix of about half and half PLA and polyurethane. So you really can't keep stuff secret when you've got to make an MSDS. Basically, this stuff is half PLA, half TPU. Who knew? Me? Probably everyone. So what if you don't have a multi-material machine? Well, one final point, and this is important, so I hope you're still here. The thing about these support materials, and this also applies to PVA, or it can, you can use a lot less of this stuff than you think you need to. If you use the second material, that is the support material, for the whole of the supports, then it is quite wasteful, especially on a bamboo machine where you are purging whenever you change colours, and it takes more time on any multicolour machine. But of course, it's unfeasible on a single extruder. Nobody wants to do 2 changes every 2 layers manually. But if you think about it, the only thing that you need to break away is the interface. So you could just use the support material for the interface. You should be able to see on screen how much filament poop that saves on a bamboo, on a random piece. But also, if you have a single extruder and you choose to do only 1 layer of interface, I mean, you could do 2, I think that's the standard 2. If your area you're supporting is flat, like this example here, then that is only 2 filament changes for your whole model. 1 to change to the support material and 1 to change back again. I know it's really not much consolation compared to having a multi-material machine, but it could get you out of a pinch if you need it. So there you go, that is the end of this video. Let's dissolve these PVA prints and see what happens. And with that, thank you for watching.